So yeah, so those are regular, you can continue watching. So yeah, let's read the question now. Let x of n be the sequence. X of n is given as x of n is equal to delta of n plus 2 delta of n minus 2 plus delta of n minus 3. The sub questions are find 4-point DFT of this sequence x of n. Second sub question is if y of n is the 4-point CC of x of n, the CC stands for circular convolution, okay? 4-point CC of x of n with itself, find y of n and 4-point DFT y of k, okay? So what is this statement says that 4-point CC of x of n with itself? It means that whatever the sequence x of n we have, right? And whatever we do, in circular convolution, what we do, we take its DFT, and whatever answer we get, we will be multiplying with the another sequence answer and doing the point-to-point multiplication. But here in this case, whatever answer we get of this sequence, that answer we should be doing multiplying it with itself. Okay, that is whatever answer we got, that only we should be multiplying again, and that we should be doing point-to-point multiplication. After that, we should be taking its IDFT and solving for circular convolution. Okay. So now all of this is okay, but where is the sequence in the question? The sequence is not there only. They have given this equation here. But how to, using this equation, how to write the sequence? Okay, for delta of n, where this delta of n is called as unit sample response. Okay, this delta of n is called as unit sample response. Don't forget, keep it in your mind. So now what is this unit sample response, and using this equation how to write the sequence? That is, unit sample response would be of the order of n minus 1, n minus 2, n minus 3. So this is the sequence of unit sample response, and it goes on. Okay. Now here you can consider as delta of n minus 1, delta of n minus 2, delta of n minus 3. It is one and the same. Okay. So now in order to write the sequence, you should be checking these terms coefficient in the particular equation. That coefficient you should be writing in a form of sequence. For example, for this question only, let us consider, okay, x of n, it starts with delta of n. So here in this case, this is delta of n, it is starting from delta of n only, so that would be our first term, that is the coefficient of this delta of n, that is 1, right? So that is the first term, 1, comma. So here after delta of n, we know that in the sequence the next term would be delta of n minus 1, but we don't have any term here delta of n minus 1, so that's why its coefficient would be 0, comma. Next term is delta of n minus 2, its coefficient is 2, plus 2, so here we have plus sign, so plus 2. Then in the next order we have delta of n minus 3, its coefficient is plus 1. Understood, right? In this way we should be writing the sequence whenever the question is of unit sample response delta of n. In this order the sequence would be delta of n minus 1, n minus 2, n minus 3, and goes on. Okay, we should be checking for its coefficients, and we should be writing the equation. Okay, so now we got this equation here, nothing much to do. Already I've told you the procedure about how to solve, right? This sequence is DFT, you take whatever answer we get, the answer with itself we should be multiplying, do the point-to-point multiplication, and whatever answer we obtain from that, take its IDFT and find the circular convolution. Okay, yeah, without wasting any time, let's solve it fast. First is DFT x of k, that is 1, 0, 2, 1. Okay, I prefer you guys to do with the matrix method. Okay, sometimes they would be mentioning in the question specifically, that is either you should be doing either using matrix method or formula method. Okay, that time you should be doing, but if they won't be mentioning, but if they mention it, do it that way. But if they won't mention it, I suggest you all to do it using matrix method only. Okay, yeah, so 1 1, this is again 4 cross 4 matrix, so that's why I'm writing it. 1j 1j. Again I'm telling you guys, those who are new to this video, they won't be understanding anything, that why I wrote like this, why I am putting this minus sign here, because you don't know, because you have not seen the video before. So that's why please guys, please watch those videos Again, there is no time for me to explain it. Okay, yeah. So now let's multiply. So first column row would be 1 plus 0 plus 2 plus 1, since we are multiplying it with 1. The next is 1 ones are 1 plus 0 minus 2 plus j. Then we have 1 plus 0 plus 2 minus j. Then we have 1 plus 0 minus 2 minus j. Okay. The answer we get is 2 plus 1 plus 1 4, minus 2 plus 1 minus 1 plus j. Then we have oh, this is 1, right? Or minus 1. Okay, so 1 minus 1 0, so we will left with 2. So 1 minus 2 minus 1 minus j. So this answer we got, we should be multiplying with itself. Okay, with itself means again we should be multiplying with it, that is we should be taking its square. So y of k is equal to 4 minus 1 plus j, 2 minus 1 minus j, into with itself, that is 4 minus 1 plus j, 2 minus 1 minus j. That is equal to 4 4 is 16, minus 1 plus j into minus 1 plus j. Okay. Minus 1 plus I, minus 1 plus I. That is minus 2j. Then we have 2 2s are 4. Minus 1 minus j, minus 1 minus j. Change it here only. Plus 2j. So this is the sequence which we have got after multiplication. So now for this, take the IDFT and solve for y of n, that is 4 points, so 1 by 4, 16 minus 2j, 4, 2j. So IDFT, so 1 1 1 1. So here second and fourth columns are interchanged, so this is minus minus. So here 16 minus 2j plus 4 plus 2j, 16 minus 2j into j, so minus 2j square, so j square is minus 1, so that is plus 2, minus 4 minus 2. Then we have 16 plus 2j plus 4 minus 2j. 16 minus 2j into minus j, that is minus 2. Since minus 2j square, so j square is minus 1, so minus 2. Yeah. Minus 4 minus 2. So our final answer we would be getting it as y of n is equal to 1 by 4 into 20, 16, 28. So that is y of n is equal to, divide by 4, 20 by 4 is 5, 16 by 4 4, 20 by 4 5, 8 by 4 2. So this is our final answer of y of n. Okay. So those who have not seen my previous videos, it is available in my playlist. So please do watch that. Without wasting any time, let's try to understand this derivation. So the heading is frequency domain sampling and reconstruction of discrete time signals. Okay, this is from module 1. Firstly, you should be considering a Fourier transform. Okay, that is x of omega or ohm, x of omega is equal to summation of n is equal to minus infinity to infinity where x of n e power minus j omega n, okay, where x of n is a discrete time signal and this omega is a continuous time signal which has a limit of 0 to 2 pi, okay. In this way a general Fourier transform is represented. In order to obtain the DFT formula, we should be starting from the standard Fourier transform, okay, that is x of omega, okay. You wrote this. Now in place of omega, we should be substituting omega as 2 pi k by capital N, okay. So that's why x of 2 pi by n into k is equal to summation of n equal to minus infinity to infinity x of n e power minus j. In place of omega, now you put 2 pi k by n into n, okay. This much you have written, right? Now comes this scale part. Consider a scale. So now what is the scale? And according to this, how we should be writing this equation here is, this scale is for this, that is, consider one infinity scale which has a range of minus infinity to plus infinity. So now you should be splitting this summation in such a way that you should be getting our required DFT formula, okay. For that, what we should be doing is, first in center mark one point as n, okay, then here mark one point as 0, here you mark one point as minus n, okay, then here you mark one point as 2n, okay. Like that you go on marking, okay, and put this dot symbol. This represents that it is, the scale is infinite, okay. Now before n there is one term n minus 1, okay. This n is one random number, okay. It doesn't have, it is one constant value, and you know that before this constant value the previous number would be a difference of 1. So that's why I've written it as n minus 1. After this you would be having n plus 1. Similarly for 0 also write the same way, write minus 1 plus 1. Here also minus n, so minus n minus 1 minus n plus 1, okay. Similarly for this, okay. So we know one thing, that is, in a DFT formula what we have is summation of n is equal to 0 to n minus 1, okay. We have one range, right, for DFT we have discussed, okay. That range we should be marking as one single interval in the graph, that is in this scale, that is summation of n equal to 0 to n minus 1. So 0 up to n minus 1, this is one set here, okay. This is one interval, okay. For this, write this part as it is, that is x of n e power minus j 2 pi k n by n, plus like this only how we have grouped for this, right? Similarly grouped for all of them, that is from minus n to minus 1. Similarly we have from n to 2n minus 1, then we have 2n to 3n minus 1, and goes on, okay. In both sides it goes on. All of them you should be writing in the form of an equation, that is x of 2 pi k by n is equal to, then this is this dot represents that this is an infinity scale. So then you write, I have written it from here, that is interval of minus n to minus 1, and this term, if you want you can write it, otherwise you can, in order to just to represent it I have just written, I have not written these terms here, okay. Fully for this particular part I have written it because this is very important, okay. If you want you can write x of n e power minus j 2 pi k n by n to all of this here. Then like this you do, split this equation. So hope you understood this. Next step you can see here is, I have taken here summation of L is equal to minus infinity to infinity into summation of n is equal to ln up to ln plus n minus 1 into x of n e power minus j 2 pi k n by n, where L varies from minus infinity to infinity. So now how I have taken this is, observe very carefully. So if you observe all the summations, one thing is common here, okay. Why I have taken this L is equal to minus infinity to infinity, I have tell you, okay. So that this I have taken it to avoid this infinity symbols here, okay. One more thing is, why I have written n is equal to ln is, consider one L as constant, okay. For example, here n is equal to ln. So in here in case of L we have the value as minus 1, right. According to this, now let's see whether this matches or not, okay. So here if it is minus 1, then ln plus n minus 1, that is minus, so here it is minus 1n, so minus n plus n minus 1, so minus n plus n would be cancelled, we would be remaining with minus 1, so this would be satisfied. Similarly here we have n is equal to 0 to n minus 1. So in place of here, what is the value of L here? In place of L, the value of L here is 0 because we have n is equal to 0. So if you put the value of L as 0, what we would be getting? 0n plus n minus 1. So this 0 into anything is 0, this would be cancelled. We would be left with again n minus 1. Okay, so that's why. Similarly, for here also, if you consider here the value of L is 1, so Ln plus n minus 1, that is n plus n minus 1. So what is that? N plus n is 2n minus 1. So here we got 2n minus 1 and it goes on. Okay, so that's why we have taken this L here. So in order to represent this L, because this L is a constant and it has a fixed value for, that is 0, 1, 2, 3. Here in this side also it is 0, minus 1, minus 2, minus 3. So that's why I have written this summation here outside first. That is L is equal to minus infinity to infinity into summation of n equal to Ln up to Ln plus n minus 1 x of n e power minus j 2 pi k n by L. Okay, hope you understood this. So now consider n minus Ln is equal to 0. That is, this equation we can even write it as n equal to Ln or n minus Ln equal to 0. It is one and the same. So what happens here is x of 2 pi k by n is equal to this, you keep it as it is. Then here summation of n is equal to, this would be now 0 up to n minus 1 because we have taken here this term as 0. Okay, n minus Ln 0, so this term would be 0. So now in place of n here you should be substituting n minus Ln e power minus j 2 pi k. In place of n substitute n minus Ln divided by n. Okay, like this you write. Then these two things I keep as it is. Summation of n equals 0 to n minus 1 x of n minus Ln e power. Then you should multiply this. Inside terms you should be multiplying, that is e power minus j 2 pi k n by n into e power minus j 2 pi k Ln by n, where this n and n would be getting cancelled here. Okay, we would be left with e power minus j 2 pi k L. Okay, so now this term e power minus j 2 pi k L is equal to 1. Okay, how it is equal to 1, that I would be telling you now. Okay, so take Cal C, and here consider this KL. I have written where KL is constant. Consider this KL to be any number of your choice. Okay, so now according to this e power minus j theta, we have an equation that is cos A plus I sin A, right? So in this equation, this Cal C, and here consider this KL ranging from 0 to infinity. Consider any values. Okay, before that we should be multiplying it with 2 pi. Okay, so that's why 2 pi into, first let us consider 0 only. See, our answer we got is 1. Okay, next time I am considering 2 pi into 1. Again we got 1. 2 pi into 2, we are getting 1. 2 pi into 3, again we are getting 1. So that we can see that all the answers are 1 only. So that's why here we can say that any e power minus j 2 pi into anything that is constant 0 to infinity, if you multiply by anything, our answer always would be 1. So that's why this whole term would be cancelled. It would be equal to 1. Then write rest of the things as it is. X of 2 pi k by n is equal to summation of L equal to minus infinity to infinity. Then write these terms as it is. Here we have 1. Then what we should be doing is then write the final formula. X of 2 pi k by n is equal to summation of n equal to 0 to n minus 1 x suffix p of n e power minus j 2 pi k n by n, where k is equal to 0 to n minus 1. Okay, so this is our final DFT formula. Okay, right, we have obtained the DFT formula here. This is the frequency domain sampling part. Okay, we have one more part, that is reconstruction. That is, from this we should be obtaining IDFT. Okay, so where here this xp of n stands for this summation of L is equal to minus infinity to infinity x of n minus Ln, that is equal to xp of n. Okay, this is a discrete function. Okay, you can keep here in mind. So this much if you write, you would be getting around 4 to 5 marks. We have still more writing part here. Now after this, the next step what we should be doing is aliasing part. Okay, what is this aliasing here? Okay, now let us consider x of n contains L samples and let L is equal to 4. Okay, case 1, n is greater than L. Okay, so here n is the number of samples in the frequency domain and L is the number of samples in the time domain. So here in this case, let us consider n to be greater than L, that is, let n is equal to 6 here. Okay, here the sample values, and here we have considered L is equal to 4. L is equal to 4, we can consider any 4 values and we can plot the graph. Here the sample values at n is equal to 4 and 5 are 0, therefore there is no aliasing. So now what is this aliasing? Aliasing means overlapping. Okay, so now how I would explain how this aliasing will be taking place. So here draw one graph here like this, mark the scale 0, 1, 2, 3 up to 10 or something. Here we want 0, 1, 2, 3, 4, and the 4 values in this case I've considered are 4, 3, 2, 1. But here in this case the value of n we have considered it as 6, right? So that's why plot the 4 points starting from 0, that is 4. In the 1 we plot 3, 2, 1. Then after that, since the value of n is 6, we should be marking this same periodic signal up after 6 points. Okay, that is 0, 1, 2, 3, 4, 5. Then from 6th point, do the same marking, that is 4, 3, 2, 1. Then again we would be getting 2 values as 0, because after each 6 points you should be plotting the graph, right? So here after these 2 points, here we would be getting 4, 3, 2, 1 like this. So here we can say that there is no aliasing. Aliasing means overlapping is not there. Here we would be getting one periodic function in with certain gap, because here the condition is n is greater than L. Okay, so that's why here we have no aliasing. But when does this aliasing or overlapping occurs is whenever this condition, whenever we have n less than L, this aliasing would be taking place, that is overlapping. For example, here I have considered n as 6, so now let's consider n as 3. Okay, let the values be the same, 4, 3, 2, 1. So I have not marked here. Okay, so here n as 3 I have marked. So after 3 points you should be marking the points, right? But here the first value is 4, 3, 2, 1. Okay, so now n is equal to see through 3. So after 3 points, that is 0, 1, 2. So from this point only we should start again, that is 4, 3, 2, 1. Again after 3 points, again you should start from here. So here we can see that 2 signals are overlapping here, right? So this condition is called as aliasing. Whenever to avoid aliasing in time domain, the number of samples in frequency domain must be greater than number of samples in time domain. Okay, this is the one condition you should be knowing. So that's why we have done this, in order to prove that n is greater than or equal to L. Okay, in order to avoid aliasing, this is the condition. So how the aliasing process is clear, right? Hope you understood this. So you should be noting this down after that. Then after that, the final part is reconstruction part. Okay, reconstruction part is in order to obtain the discrete Fourier transform. This reconstruction part is there. We should be considering a Fourier series now. In the frequency domain sampling, first we have considered Fourier transform. So now here we should be considering Fourier series, that is x of n is equal to k is equal to summation of k equal to 0 to n minus 1 c of k e power j 2 pi k n by n. This is one general formula for Fourier series. So here in this case, this c of k is represented as 1 by n summation of n equal to 0 to n minus 1 x of n e power minus j 2 pi k n by n. Okay, so in this equation now, substitute the value of this is there right here. This here we have just now we have derived it, that is equal to x of 2 pi k by n, that is the DFT. Okay, so now in this equation substitute this as this, that is a DFT. Then c of k is equal to 1 by n, summation is not there, x of 2 pi k by n. So now x of n is there, right? So here this is the value of c of k we got. So now in this first equation substitute the value of c of k, that is x of n is equal to 1 by n, you put it outside, summation of k equal to 0 to n minus 1 remains as it is, x of 2 pi k by n, that is the DFT, x of 2 pi k by n, or in the formulas we have derived it as x of k, okay, into e power j 2 pi k n by n, where n is equal to 0 to n minus 1. So in this way you should be getting the reconstruction plot, reconstruction equation, okay. So yeah.